Group 7, and in this video, we will discuss and dive deeper into the process of evaporation. To better understand this process, let us first answer the question, what is the physics of evaporation? But before jumping into that, let us first define what this process is. Evaporation is the process by which water changes from a liquid to a gas or a vapor. This is the main route for water to return to the water cycle as atmospheric water vapor from the liquid state. Evaporation commonly occurs in everyday life. When you get out of the shower, the water on your body evaporates as you dry. If you leave a glass of water out, the water level will slowly decrease as the water evaporates. The physics of the evaporation process is based on the process of providing sufficient energy for breaking the bonds between water molecules. The fact of supplying the system with heat causes water molecules to become increasingly movable, which results in increase in distance between them. The higher temperature is, the more water molecules escape the surface into the lower layers of the air, or the liquid water transformed into gaseous state. The physical cause for this phenomenon is called the Brownian movement. For changing the aggregate state from liquid to gaseous, it is necessary to provide higher amount of energy, which is 2,450 joules per gram, and then for the melting process, or 340 joules per gram. In other words, evaporation is loss of water from a wet surface through its conversion into its gaseous state. Surface can be bare soil, for soil evaporation, open water, including river, lakes, and oceans, or intercepted water held upon plant surfaces, or interception evaporation.
Here are the various factors affecting evaporation. One is temperature. The rate of evaporation is directly dependent on the temperature it's exposed to. The more the temperature, the more liquid it's exposed to. The kinetic energy increases and the liquid gets converted to vapor instead. This increases the rate of evaporation. You must have noticed that clothes dry at a much faster rate during summers than in winters when the temperatures are higher. Number 2, surface area of the liquid. The rate of evaporation is directly dependent on the area liquid that is exposed to. Let us take a look at some practical examples. The cloth is usually spread over the cloth line so that it gets exposed to more surface area, and that makes the water evaporate. Then, we all put our daily cup of tea into a saucer so that it cools down quickly. It is simply because some of the particles get evaporated, leaving the tea at a lower temperature. Number 3, humidity of the air. Evaporation depends greatly on the water vapor present in the air. The lesser the water vapor, the quicker the cloth gets dry. The more there is water vapor in the air, the more time it takes for the water to get evaporated and make our clothes dry. Fourth, wind speed. The more the wind blows, the greater is the rate of evaporation. Wind increases the kinetic energy between the water particles and the rate at which the water gets evaporated. Take, for example, a windy day better dries your clothes as compared to a moist day. Number 5, intermolecular attraction. The viscosity of elements or compounds often affects the rate of evaporation. The molecules of water are loosely bound, while that of hydrogen sulfide is tightly bound. Hence, the time taken by water to get converted to a gaseous state is comparatively less than that of hydrogen sulfide.
The next factor is atmospheric pressure. It was noticed that places on Earth where the atmospheric pressure is lesser, the process of evaporation is more. The kinetic energy of the particles increased and then the change of status was observed. Thus, the greater the atmospheric pressure, the lesser is the rate of evaporation. Depth of the body from where evaporation occurs. The water body from where the water is evaporated is one of the main factors that can affect how evaporation occurs. Thus, if the depth of a pond is too much, the rate at which the water will evaporate will be greater. Vapor pressure difference. The rate of evaporation clearly depends on the vapor pressure of the air, or the rate at which the air leaves the surface. The difference between the vapor pressure of water and the vapor pressure of air is another primary factor that affects evaporation. Presence of solutes in solution. When salt is present inside water, the rate of evaporation increases. The simple reason is that the boiling point of salt is greater than the boiling point of water. As a result, the concentration of dissolved solutes will be more than the water itself. And lastly, the influence of magnetic field in evaporation. The influence of the magnetic field affects the rate of evaporation. The magnetic field affects the viscosity of the liquid and increases water tension. This results in the increase of the rate of evaporation.
Measurement of evaporation. Evaporation is usually measured by evaporation pans and thermometers. Evaporation pans are most widely used for measuring evaporation. It is affected by the size, depth, and location of the pan. There are types of evaporation pans. First is the Class A evaporation pan. It is a standard pan of 1,210 mm diameter and 255 mm depth used by the US Weather Bureau. Second is the ISI standard pan, also known as the modified Class A pan, consists of 1,220 mm in diameter with 210 mm of depth. Third is the Colorado Shotgun pan. This pan is 920 mm square and 460 mm depth, and is made up of unpainted galvanized iron sheet and buried into the ground within 100 mm of the top. Lastly, the US Geological Survey floating pan, with a view to stimulate the characteristic of a large body of water. This square pan is 900 mm side and 450 mm depth, supported by the drum floats in the middle of the rock.
So what are the available methods, procedures for estimating evaporation from open water? There are 7 methods of estimating open water evaporation: pan evaporation, mass balance, energy budget models, bulk transfer models, combination models, the equilibrium temperature method, and empirical factors. 2 methods are recommended for estimating open water evaporation: empirical factors and the equilibrium temperature method. The first relies on multiplying estimates of potential evaporation for gas by empirical factors to obtain estimates of open water evaporation. The equilibrium temperature method is more rigorous in that it estimates the open water evaporation by combining the radiation balance and the aerodynamic function.
Here are the references for this video.